Good afternoon, and thank you very much for joining us today. My name is Lisa Mackenzie, and I'm the Marketing and Communications Manager at the European Marine Energy Centre, also known as EMEC, based in Orkney. I'll be your host for this webinar, which will delve into the ReFLEX Orkney project and the learnings that we'd like to share for the smart local energy system of the future. Now, I'm joined today by my colleagues from across the ReFLEX Orkney partnership. My colleague Neil Kermode, who is Managing Director of EMEC and ReFLEX Project Director, Gareth Davis, John Thowlas and Anna Marriott from Aquaterra, who have been instrumental in setting up the energy services entity ReFLEX Orkney Limited, Mark Hamilton from SMS, whose innovative FlexiGrid was being used to demonstrate the smart element of the project. We've got Evelyn Lee from Community Energy Scotland, which led on the community transport side of the project, and David Jenkins, Harriet Watt, who will provide insight on the systems modelling element. So some quick housekeeping before we get started. We've allowed some time during the webinar to answer some of your questions. So if you do have any questions, please submit them into the Q&A function. So not into the chat, but into the Q&A box. And that just keeps them very neatly in one place for us to look at. And please note that the webinar is being recorded, so we will share it on YouTube for future reference. So the ReFLEX Orkney project is one of 3 demonstrator projects match funded by UKRI through the Prospering from an Energy Revolution PFER programme. And this aimed to accelerate innovation in smart local energy systems. So as an introduction, I'm going to pass you over to Gareth, Gareth, can you introduce the ReFLEX concept and the aspirations of the project, please?
Yeah, delighted to do that, Lisa. So the ReFLEX project it's more than just a research project. It's actually an initiative which really came out of, I think, 20 years of experience of living with an energy system in Orkney, which was starting on that transition to decarbonisation, but had a long, long way to go. And at its simplest level, ReFLEX was about trying to join the various bits of our energy system together in a more flexible and connected way. And the reasons for that were to allow us to start to move energy loads from one place to another where it made sense, to avoid some of the peaks and troughs, and also to try and look at where value was being lost out of the system. And as customers, we might have been paying for that lost value rather than actually benefiting from it. So that idea of connectivity of demand and supply across digital platforms, embracing the technology of today, was very much at the heart of ReFLEX. But the motivation for coming up with those ideas was more deep-rooted in the experience that we'd had with our energy system to date. And if we think about that energy system, next slide, please. If we think about the energy system that we were living with, we had a number of challenges that were associated with that current utility offering. And those challenges were technical challenges in terms of the capacity of the system, the reliability of the system. It was certainly challenges in terms of being able to put new renewable generation onto the system and some of the obstacles that we faced. But there were also customer service issues and cost issues. And of course, if we think about our energy system, this isn't just the electrical energy system, but we also have to think about our fuel-based energy system as well, because what we're seeking to do in ReFLEX is bridge across between electrons and molecules and bring those things together. So ReFLEX was really about trying to take the high ground, if you like, and think about the things that would make our energy system better for us in terms of its affordability, make it more responsive to our needs, and in particular, driving that acceleration towards decarbonisation, which is so key, not only for us, but also for the rest of the world. Next. So what we wanted to do was embrace the totality of our energy system, thinking about electricity, heat, and fuel, and how we use those in many different ways in our lives, in our households, in our businesses, and in our public buildings and spaces. And we've developed this idea of what we call the energy services circle, which is reflecting all the different relationships that we have as householders, as businesses, or as public bodies with our energy supply. So conceptually, that's the spread of what we were trying to achieve. It's quite a broad-based basis. We're trying to achieve change and transition in imaginative ways. And what we wanted to do then is try and understand the quantification of it. And I'll just hand over to Neil to take us through some of the background that we reached on that.
Thanks, Gareth. One of the first and underpinning activities that was undertaken in the project, and that was undertaken by Aquaterra, Gareth's company, was that of an energy audit. And the energy audit was built on some work that was done some years earlier, about 5 years earlier, and it looked at how the county and the community uses energy. And the audit effectively discovered and disclosed the way in which we operate and indeed the fuels we're using. So the second column there shows the fuels. This is a Sankey diagram, so the breadth of the line is an indication of comparative magnitude. And you can see that kerosene is about as much as used as much as electricity is in our world. But not only that, we were able to see where the energy was used in particular types of activity, and that basically breaks into a couple of parts. But the most telling thing of the whole thing is that heat and light is a significant proportion for us in the community, as it is for any, but also transport is really big for us here in Orkney. And our transport, being an island, is different to some other locations, and so there's a chunk of land transport, a chunk of air transport, and a chunk of sea-based transport. And those transport mechanisms, you can see, are frankly as important, if not more important, than the heat and the light aspects. And for that reason, the project looked to go across this whole range, and you'll hear shortly about the different parts of the projects which looked at both the vehicle side of things, which was big for us, but also other elements in terms of energy flows as a whole, and also the use of heat. And so the point is that what we've done so far as a community, we've been very successful at introducing renewables and pushing on with this for a number of years. And that's meant that we've basically decarbonised our electricity system. Now, not entirely, because what happens is we have produced more electricity than we have needed every year since 2013 in Orkney, and we've done that from renewables. But it does mean that on occasions we have to buy in electricity from outside, and we then export electricity in other parts of the year, and that balance is naturally changing as more and more renewables come onto the network. But the point is, we quite often self-congratulatory about what we have done, but you can see there that in effect, we've done a certain amount of electricity, some bit of the electrification of transport, be it substituting road diesel or indeed petrol, but frankly, only about a fifth of the job is so far done. And so we have got some significant challenges as a community to work out how we decarbonise the rest of the rest of the 80%, or the 80% we haven't really scratched at. And so we saw the ReFLEX project as an opportunity to try and find ways to break into some of these points, because frankly, some work was done by SMS, which showed the difference between the Orkney economy and others. This has been really telling, and a great credit to Mark and his team for doing this, which looked at what the UK energy supply system, electricity supply system looked like at the moment. So basically this looked at the energy system, particularly the electricity system in the UK in 2019, and the grey line shows the electricity supply and demand that was required on the network back in August. And you can see the tooth-like structure being every day during that month. And the bottom line, the green line, is the renewable generation which was on the network. Basically the jaggedness is solar, and the waviness that underlines it is wind. And so this is the position as in 2019. If we quadrupled the amount of energy or renewables that was on the network, you would end up with this picture. So it's just 4 times as much, exactly the same demand picture. And if we compare that with what is happening on Orkney at about the same time, next slide, please, it shows that this is our position in Orkney at the moment, where we have the same sort of picture of red being above the blue. In other words, electricity supply on occasions from renewables being red is greater than our demand, which is our blue line. So we always saw what was happening in the community in Orkney, something a bit of a canary down the mine of we were able to see what the rest of the network was going to be seeing in the very near future. So that was part of our idea, to try and pioneer ways of handling this huge variability in a flexible way in a renewables dominated market. So that was the plan. Lisa, I'm going to hand back.
Lovely. Thank you very much, Neil and Gareth. I think that was a really useful introduction to the project. We're now going to delve into some of the key outcomes and learnings from the project. Anna, if I could ask you to start, because I think a really important element of the project was the community engagement and the setup of ReFLEX Orkney Limited. So can you give an insight in terms of the progress that was made there, please?
Yep. Yes. So ReFLEX Orkney Limited was, or is, the customer-facing business that was set up as part of the project. And while the project is coming to an end now, ReFLEX Orkney Limited continues indefinitely. And that is the customer-facing service based at Hatston, where people come to get products and services from ReFLEX to help them decarbonise in their lives. And give me a second, I'm just going to share my screen. So taking a look at what we were able to do with ReFLEX from the point when we launched our customer offering in December 2020 until now, we've welcomed 941 members into ReFLEX, and we chose to go with a membership model to sort of enhance the fact that it's something we want people to feel a part of and embrace, as well as it also providing us with a way to administer the grant discounts that we offered at the beginning of the project. We've also brought 215 new and used electric vehicles into Orkney. We've installed 149 electric vehicle chargers. We've signed up 217 people to the car club and delivered 5 community electric vehicles to some of the aisles, and also installed 4 public chargers in the aisles as well. Our online carbon calculator has recorded over 345 carbon footprints over the last 2 years, a number that goes up every week. And for the first year and a half of the project, we had a 100% renewable electricity tariff, which gave 115 people low-cost electricity through the first year of the energy crisis, which was very beneficial. But I mean, that gives you an idea of just some of the stats on products and services that we've rolled out in Orkney. But to me, the biggest success of this, from a community engagement point of view, is the fact that we've managed to really lodge in people's minds that ReFLEX is the place to come, not just for electric vehicles, but for people who are wanting to decarbonise in their lives. We regularly get phone calls from people saying, you know, I'm thinking about doing batteries, I'm thinking about doing solar, I'm not sure where to start, so I thought I'd call you. So even though we hadn't been able to get a battery and solar offer going during the project as we'd hoped to, it's still registered in the community's minds that this is that we're sort of a good starting point. And I would also add there that we are, now that we're past the grant funded stage and the rules that kind of dictated what we could and couldn't do through that, we are looking to have another go at heat and solar offerings this coming year. So we are going to be looking at that as well.
Great, thanks, Anna. So I think ReFLEX is probably best known locally, at least, for its work around the electric cars. And I'm wondering if you and John could come in. I know you've got some really interesting stats to share around that.
Yep, I'll start just if you want to switch to the next slide. So this is a really wonderful slide that shows the DVLA's own figures of the growth of EV ownership in Orkney since 2013. And basically it was an average of about 42 vehicles a year up until the point where you can see the commercial launch for ReFLEX Orkney happened. And then suddenly there's a big spike over the last 2 years with 194 EVs we've brought into Orkney. That has basically more than tripled the ownership in Orkney in just a 2-year period of time. So we're really happy with that result. And with that, I'll hand over to John, who will take you into what we've learned from the vehicles.
Okay, hello everybody. Thanks, Anna. Yeah, I'm just going to talk a little bit about the information that we've collected from the fleet of EVs that we've rolled out over the last couple of years. And the way we've done this is by installing telematic devices in some of the vehicles. And these devices are essentially like a small mobile phone that fit into the onboard diagnostics port on the vehicle. And allow us to collect certain information like energy consumption, miles consumed, and things like that. The reason for putting these in really is twofold. It's to get that data and so allow us to understand the performance of the EVs, but also do things like carbon reduction calculations, so we can understand the energy and mileage and things like that. But also as part of the integration of the vehicles into the wider energy system, we can understand things like the state of charge, so the amount of battery capacity in the vehicles, and that's useful information for knowing when charging is needed of the vehicles. So just for today, I'm just going to share a few slides just on some of the information that we've collected from the telematics exercise. So the previous slide was just the fleet, just jumped on there, but not to worry. The two main vehicles, probably no surprise, very popular vehicles in Orkney are the Nissan Leaf and the Kia e-Niro. So those are the ones we've monitored the most information from. But as you can see from the graph there, there's other vehicles that we have been able to track information from. And overall, we've been able to get about 80% of the types, makes and models that have been delivered to Orkney covered through this exercise. So it's a fairly extensive exercise in terms of getting data. Just flip on to the next slide. This is just a chart over the last almost 2 years now of just the average distance per week covered by that fleet of vehicles. So you'll see we're averaging about 150 miles per week, so around about 7,500 to 8,000 miles per year for the whole fleet of vehicles. Just jump on, Lisa. In terms of efficiency, the way we've measured efficiency is fairly common. It's basically miles per kilowatt hour, so instead of miles per gallon, miles per kilowatt hour of energy. And this again is an average for that fleet over the whole of last year. So just watch the y-axis there. It's not zero, so don't get too worried about the January and December figures. Obviously quite low, but as it appears, but there it starts at 3 on the left-hand side there and rises to 4.2. So that's your range that you're looking at over a season, basically from the colder months through to the warmer months. And that's useful information at a high level. But if we break it down on the next slide, we can go down to individual make and models. So the bulk of the vehicles, the cars, are in the higher band there, and you can see the sort of range we're looking at over 5 miles per kilowatt hour on a Hyundai Ioniq there, and the e-up as well, the very popular smaller car in Orkney that's performed well over the years. The lower line there is actually for a van, largely business use, obviously a heavier vehicle, normally fully laden for journeys. So you'd expect a lower performance of that. But it just shows the sort of resolution of information that we can get from the telematics on the vehicles over the year. Just move on to the next slide, please. One area that we looked at a bit more closely was the impact of heating on the vehicle. Obviously, with an electric vehicle, you don't have any heat from the engine, waste heat, if you like, that you can use to heat the cabin space. So manufacturers approach this in 2 ways. They either provide direct electric heating, sort of resistive heating, as we call it, or they provide like a heat pump, so it's like an air conditioning unit in reverse, and that provides a more efficient way of heating the vehicle. So this graph here shows an e-Niro 2, which is that the bottom green line, which has got the resistive heating, and then the e-Niro 4 Plus, the upper blue line, which has the heat pump. So you can see there, an improvement, probably of the order of about 10% in the efficiency, again during those colder months by having the heat pump. So just to stress, this is obviously for Orkney, and the vehicle's been in Orkney, so it's reflective of the, if you like, the seasonal impact or seasonal effects across the 12 months. Just one other quick thing, just to highlight, and probably slightly get controversial here, but just in terms of how people drive their vehicles, and there is a different way of driving an EV. Unlike a petrol or diesel engine, you don't get any sort of energy coming back in when you're braking. But obviously, the benefit of an EV is that when you do brake, most of the braking actually can regenerate that energy back into the battery. So you probably get a more pronounced effect between harder, more accelerating driving, and people are probably easier on their driving and use that regenerative braking. So we tried to plot that here. Towards the left there is fairly heavy acceleration with the higher lines. Towards the right is deceleration, where people are able to take advantage of that regenerative braking. And you'll see a general trend across in the green line in terms of the efficiency of the vehicles. Generally, it's higher towards the right hand end of the range there. So that's the EVs. I'm going to hand you over to Evelyn, who's going to talk about the wider EV picture and what we've been doing in the communities.
Great, thanks, John. Hi, everyone. So yeah, we worked with 4 community groups to increase mobility, increase service flexibility, and decarbonise community transport. So that's just transport that's run by the community for the community. So the Island of Hoy Development Trust, ED Partnership, and Shappensea Development Trust were all interested in an electric minibus. And through conversation, we're able to identify that there could be benefit to having 2 smaller vehicles over one sort of larger minibus. And that's because it's easier to access some properties with a smaller vehicle. Some different trips could be happening at the same time. One vehicle could charge while the other was in use. And quite often, a smaller vehicle was actually going to be sufficient for the trip that the community was going to do. So each community group now has a 7-seater electric Nissan ENV 200 and a 5-seater version with wheelchair access. And you can see that in the picture on the right there. So they all offer an alternative mode of transport with reduced need to drive personal vehicles. And so while the assets there are the same, the financial situation, the skill sets, and the priorities for community groups are different, which is totally normal. And so the way in which we actually delivered the vehicles and the way that the vehicles were used was different also. So during lockdowns, they were used for delivering food and goods. And they're now used to transport people as well, which is great. So for an example, there is a hospital shuttle and one's used as a school bus as well. And so all of this has been happening while decreasing the dependency on imported fossil fuels for transport. So in just under 1 year, over 2,500 trips were taken by these vehicles, resulting in 15,000 miles driven. And our estimates are that's over 5 tons of tailpipe emissions avoided per year. We also installed some chargers, and again, each community group took a different view as to how they should be used. So some are for use only by community vehicles, and others are available for anyone on the island, so increasing the amount of public charging available. We also worked with PAPI Development Trust to introduce 4 new e-bikes to their bike hire scheme. And so those are available for hire by anyone on the island. And it's just sort of another mode of transport, increasing sort of active travel and making bike hire more attractive and potentially manageable for potential users. Another alternative transport option we've looked at is car clubs. So these are effectively groups of people sharing cars. They've been shown to result in less vehicles on roads, more active travel, and less tailpipe emissions. Back in 2020, 269 tons of carbon was saved in Scotland through use of a car club, and that was with mostly non-electric vehicles. In Orkney, all of the car clubs are electric. The first is run by Rousey, Egglesey and Wire Development Trust, and that actually predates the ReFLEX Orkney project. In 2019, we ran a transport survey and discovered that mainland Orkney ferry terminals were considered very useful for a car club site. Orkney Housing Association at the time were also partnering with Co-Wheels to trial 3 locations in Orkney through the Plugged In Households Fund. And Co-Wheels Car Club is a pay-as-you-go car hire provider. You can join as a member and then book the vehicle to drive wherever you want and return it where you picked it up. So we worked with Co-Wheels to set up cars at the Kirkwall Pier and Ulrich, also known as the Old Academy, in Stromness. And co-wheels have cars spread across the UK, including near the Aberdeen ferry terminal. So anyone joining the co-wheels car club can hire vehicles in Orkney and across the rest of the UK. So one of the models we looked at was at the Kirkwall Pier, and the benefit of that was that Isles residents travelling by the pier could leave their car on their island and actually pick up the EV once on mainland Orkney. So you're reducing the amount of vehicles coming across on ferries, and the location is also great for anybody in Kirkwall to hire the car as well. So we've had one second-hand Nissan Leaf available for just about 2 years. And at the moment, an MG ZS, another type electric vehicle, is currently at the pier and available for hire. So in Stromness, the car club model was slightly different and was designed to be focused around local business use, or Monday to Friday, with the vehicles available to public in the evenings and weekends. However, the timing of when we were trying to put these in place was just as COVID-19 was starting to surface. So that resulted in more working from home. And so the car club's mostly been used by residents. So 3 second-hand Nissan Leafs were deployed in 2020, and there's currently one available for hire in Stromness as well. So at the Kirkwall Pier alone, more than 250 trips have resulted in nearly 10,000 miles being driven. And so we reckon that's about 2.5 to 3 tons of carbon avoided from petrol and diesel tailpipe emissions. The car club in Orkney is still pretty new, with just over 200 members based in Orkney. And as the use of the car club grows, our hope is that fewer personal cars will be needed, which reduces the emissions associated with manufacture of the cars, as well as the cars actually being used. So the car club in Kirkwall and Stromness is continuing and with new vehicles, but I'll save that for our discussion on next steps later. But while we are talking about vehicles, Neil, I think you have quite an interesting observation about EV statistics in the UK, if you wouldn't mind sharing that.
Yeah, thanks, Evelyn. It was really interesting because the graph that Anna showed earlier with the line of the vehicles, the number of vehicles recruiting, oh, thank you very much indeed, just like that, like magic, shows the sort of the yellow line. And when we started to bring the ReFLEX vehicles in, we noticed the line didn't kick up. And it then transpired in further discussions with Office of National Statistics that the information they are recording seems to be faulty, in that the vehicles that are shown for Orkney are only those which are registered in Orkney. So lease vehicles actually show at the location of the lease company's home address. Now, we think this is a flaw because in terms of the public provision of electric vehicles, it's going to be really difficult to know where the vehicles are, because this is the only data set that seems to be available. So we unearthed a glitch which was buried deep within the interaction to ONS and DVLA, and part of the use of the project is where we can find these problems, being able to flag them, and hopefully they can then be addressed to better ensure that we understand what the data is really telling us.
I think that's a really interesting observation, because it just shows the importance of doing these demonstration trial projects, that you can learn so much more than what you even set out to learn. There was one other element that I was going to nip back to, because John mentioned that driving EVs is quite different to driving a conventional vehicle. And Anna, I think doing the test driving found how beneficial it is just getting people in a car and doing some test driving. Would you be happy to share just a little bit about how important that was for the project?
Yeah, definitely. I mean, one of the things that we found is that the vast majority of the vehicles that we leased were vehicles that we had here in Orkney for people to test drive, because most of the people who took cars from ReFLEX, it was their first experience driving an electric car, but it was also their first experience leasing. So having vehicles they could actually come and try for themselves for the first time made a huge difference to what people chose to take. But also, I think it's just having done a lot of test drives with customers myself, it's really fantastic, because people think when they come to get an EV and they've not driven one before, they'll sort of say, well, it's the right thing to do and I should be doing it now and it makes sense with the economy to give it a go. But they expect it to feel like a compromise. They don't realize they're fantastic cars to drive. And it's great when you take people out for a test drive, and within about 5 to 10 minutes, once they get used to the handling and stuff, they're like, wow, this is great. And you just see the penny drop, and they realize, you know, they're great cars to drive. It's not a compromise. It's a step up in many different ways.
Definitely. Thank you very much, Anna. So we'll move on to another key part of the ReFLEX trial, which was looking at smart EV charging and a curtailment reduction trial. So John, are you happy to come in and share some of the findings around that?
I'll give it a try and test the technology. But yeah, 2 parts here. So I'm just going to talk a little bit about what we've been doing locally with the EVs, the EV chargers, and how we've endeavoured to integrate those into the wider energy system. And then Mark's going to come in and share some of the wider SMS experience at a national sort of transmission level on the network. So hopefully this will work. So coming through. Come through okay? Yeah, okay. So yeah, just in terms of how we've gone about looking at the integration of the assets we've rolled out there. This is a map of the Orkney electricity grid, and basically I've just put it up to show how the network runs from the mainland of Scotland down here around the islands. But the key thing is that at various points on this network, we have areas, the points that are measured by the network operator, where the grid is potentially full at certain times. So if there's a lot of wind on the system, the network gets full, and what happens is that those wind turbines then need to be pulled back. Basically, they need to be curtailed. Over the years, we've looked at this at various times, and we found that, you know, in some years, if the winds are high, maybe demand's a bit low, grid is heavily constrained, we could possibly lose up to about 1/6 of our renewable energy capability in Orkney. So that's basically lost energy, and it's lost value for the islands. EVs actually provide a great complement to this sort of, if you like, intermittency of wind energy. You know, most of us use probably our cars probably 3, maybe 5% of the time. So the rest of the time they are sat there, their batteries sat there, and they make an excellent flexible load on the network. So what we tried to do locally with the trial is try and encourage charging of vehicles from just regular charging, which is illustrated at the top here. So maybe people are putting on their vehicle on every night, or, you know, every 3 days, charging it up, and it's sort of regular charging, which is not coordinated in any way. The wind comes along. This is the output from wind turbines, and we get these periods when we've got too much wind for the grid. These grid full measuring points. So we're losing energy at these points here. So what we try to do with the trial is basically shift the charging, or encourage people to try and put their vehicles on charge when the wind output was high. So we could hopefully absorb some of that wind capacity, or that wind energy. So the setup was shown here in the middle. Basically, we managed the customer interface. So people who had got an EV and an EV charger, this was managed by ReFLEX Orkney, working closely with SMS and their FlexiGrid, which is an aggregation, cloud-based aggregation platform that would talk to the EV chargers through here, and we'd also pull in data from the wind turbines to try and understand when these wind turbines might be curtailed. And the intention was to try and, as a previous diagram was trying to reduce the amount of demand on the system when the wind was low, and then try and increase it when the wind is higher. I'll just share with you briefly just you know, one of the trials that we conducted back in February. This was during a period of high expected wind speeds, and therefore high expected curtailment. So at this day, for Thursday the 23rd of February, we had a 94% chance of a risk of curtailment. This is just a prediction tool based on load on the network and wind speeds. And what we tried to do then was basically target the charging of the EVs to coincide with that period of high probability of curtailment. So the trial started here. So people have asked to plug in their cars at this point, and depending on how they plugged them in and what the capacity of the battery was, determined what they were taking at that particular point in time. We then took control of these chargers under the aggregation platform. So you'll see that the chargers, whatever level of power they're pulling here, here, and here, we basically took down to the minimum for those chargers. kept it down at that level, and then when we expected the curtailment, the high probability of curtailment, we basically switched on all the chargers. So you'll see them all coming on here and consuming energy. So the idea, as I say, was to try and align that with when we've got periods of high wind curtailment and potential for high wind curtailment. So it just shows the capability to do this at a local level. This was at a small scale, but you know, as you scale these things up, you can bring more load on and hopefully have a bigger impact. So I'll hand over to Mark now, who can talk probably about the bigger picture and activities.
Yeah, thanks, John. So as John alluded to there, we're really only scratching the surface here in terms of the future potential for EV charging to play a big role in flexibility delivery to the system to manage intermittency of renewables. National scale, we're now at a figure of around 700,000 EVs on the roads in the UK. That represents an average charging capacity of somewhere between around 4 and 5 gigawatts of flexibility potential. That's really starting to be quite significant, but with the exponential growth in EV charging, we're going to get up to many tens of gigawatts worth of peak EV charging capacity on the network. If all of that charging isn't coordinated and the smartness of charging isn't brought in, then that's going to be a real problem on the network at that peak charging capacity. But if it's done in the right way through smart control, then that capacity can play a really important role in managing the intermittency of renewable generation. So we're starting to see some an increased kind of level of smart charging happening across the UK. What we're doing here is a very, very small scale, just tens of EVs participating in these trials. There's around 600 EVs on the network on the roads in Orkney today. That's a charging capacity of around, peak charging capacity around 4 megawatts. So that can start to play a significant role in managing the local constraints in Orkney. But at national scale, we have been involved in a number of trials where we're looking at delivering services not just to the DNO in terms of local constraint management, but delivery of smart EV charging to provide system services to national grid. So that from an overall UK point of view, the EVs that are participating in these smart charging trials and pilots and schemes can be shown how they can deliver very significant levels of benefit to the UK grid. I think that covers the EV charging side of things. I think the other thing just to mention here is, while the focus was on EV charging in the ReFLEX project, our platform, our aggregation platform, has also been designed to manage loads from many other types of flexibility asset, namely battery systems, electric heating systems, heat pumps, storage heating. All of these types of assets can come together to be coordinated as a virtual power plant system to deliver this flexibility. But the real focus in ReFLEX project was around EV charging. So I think back over to Lisa for the next phase. Yeah. You're on mute there, Lisa.
Thank you very much, Mark and John. That was really interesting. Just a reminder to everybody that is watching the webinar today, if you do have any questions for any of the panelists about anything you're hearing here, please do put it into the Q&A function, and after the next presentation, I'll pick up some questions then. So far, presentations have been quite EV and EV charger heavy. The ReFLEX project was looking at how to integrate transport, heat and power across the whole energy system. And Harriet Watt's role in the project was to look at how the interaction between the end users of information and the models used to provide that information, how they can interact. So David, would you like to come in and provide some of the insights that you've done around the systems modelling in the project?
Yeah, thanks, Lisa. I don't know if you're able to share the slides again, maybe from slide 28 would be great. Yeah, so from a modelling perspective, with a project of this type, the kind of early decisions that we had to make was whether to take a kind of all singing, all dancing approach to energy system modeling, where we're trying to encapsulate the entire energy system in Orkney, but maybe trying to make or having to make some compromises on detail of output. Or you take a more kind of jigsaw piece approach, where you identify the detail that you need, model that properly, and then jigsaw some of these different models together within a wider piece. So we took more of the latter approach, because we'd identified certain questions that we wanted to answer from an end use audience, and I'll touch on that in a second. So we describe this as a kind of toolkit approach. So we build up a box of tools that we think can answer some of the questions that we think are most important for the area that we're looking at. So those different areas that we modeled, firstly around transactive energy modeling, so looking at the impact of peer-to-peer and local trading, but also supported by distribution network models and battery models, and that was carried out by our team in University of Glasgow. We also looked at Heriot-Watt, my own institution, statistical modeling of EV telematics data, but also energy demand data. And then finally, we also developed a community energy model, which is what you can see on your screens at the moment. So this was populated by, first of all, GIS data to describe the buildings themselves. So that kind of multicolored picture you can see there is automatically picking up different building types from GIS data and assigning them with sort of dimensions and shape information. We then cross-referenced that with energy performance certificate data. So we're less concerned with the output of those energy performance certificates, but the assessments themselves record the building materials and the heating systems that are present, so we can cross-reference that onto our building shapes. We can then produce these reasonably detailed three-dimensional models of our community, of those buildings, which you can just see on the right of that graph. And then we can model these in a lot more detail than you would usually have within a sort of traditional building stock model or within an EPC model. So we can do essentially what we like with the energy demand profile of those buildings. We can look at them in a bit more sort of higher temporal resolution, but we can then run future scenarios through that community quite efficiently, quite effectively, to look at different insulation levels, different climates, different heating technologies, different penetrations, and produce an aggregated, simulated energy demand profile of that area that can then be of use to other parts of that energy system. So, and then what we're also able to do, because with these more detailed models, we need to know what's happening within those buildings. We need to understand activity and occupancy at a higher detail than, as I say, a traditional model. We're also able to pick up smart meter energy data. So we can do that at a national level to apply sort of typical generic profiles of operation, or we can pick up local smart meter energy data, subject to obviously GDPR and data security issues, and map that onto the building stock that we're looking at. And within the ReFLEX project, we did carry out some smart meter energy monitoring for a sample of homes. So that allowed us to see not just activity profiles, but by using sort of pattern recognition, we can tell within those data sets what type of heating technologies might be used. And again, we can map that onto our simulation environment of that community to play about with the shapes and sizes of energy loads. And if we just flick onto the next slide, just to get across this idea that we weren't just a team of modelers modeling for the sake of modeling. We had very clear goals in place. So we had an early workshop with project partners, but then a later workshop with a wider audience, where we were essentially asking end users of models, what do you actually need to know to conduct your business, whatever your business might be. So we were able to identify clear types of outputs and also data sources that we use by these end users, whether it's people interested in energy performance certificates or people want to know peak energy demand data, people interested in single buildings, aggregated buildings. We can map that back to, right, well, what from our toolkit, what tools are we going to drag out of that box to actually help answer these questions, and we can tailor those models to suit. So, I mean, that was, I think, a key part of the ReFLEX engagement and dissemination, was trying to understand who wants these models and what type of models would actually be of use to them. I shall pass back to Lisa.
Thank you very much there, David. So we've got a question come in the chat, which is directed at the curtailment trials. So looking at Mark and John to answer this one. Was there any feedback from the participants of the curtailment trials, and how easy was it to participate?
Yeah, I can take that one, Lisa. Yeah, I think the customer engagement was good. We ran some initial briefing sessions online and provided some written comms out to everybody to give them an opportunity to take part. We got feedback during the trial, which I think was very helpful. Even simple things like making sure the instructions to when to plug the charger in and what setting to put it on. We got that back from people, which was good. And then just around the comms, just given it was a technical trial, we basically used email. Then we started using text just to try and notify people, give them enough notice. I think as we go forward, it has to be a slicker. It's probably a bit clunky, and it relied on people's good deeds, if you like, to take part. I think going forward, we would need to probably make it slicker and easier for people to interact with it.
Thanks, John. Is there opportunities, I realise that this is kind of the end of the project, but is there opportunities for people to take part in similar trials like this in the future? Yeah, we would like to, Lisa. I think there was trials done previously with heating, and I think you've seen today, with the extent of decarbonisation activity that we still need to undertake in Orkney, there's an opportunity to bring in heating and EVs. EVs are only going to grow over that time. So yeah, I do feel it's a growth sector, and we would like to do it on a larger scale in the future.
Yeah, certainly. Sorry, Lisa, I was just going to add to that. Yeah. Yeah, as we said earlier, we're really scratching the surface here in terms of the potential for smart charging of EVs and smart control of electric heating to add to the capacities available for this type of grid management. Obviously, there needs to be something in it for the customer. The end customer needs to will want to be incentivized to participate in these programs. That incentive can come either in the form of cashback type rewards, or potentially could be done through electricity tariffs. We're seeing quite a few EV specific tariffs coming along, or dynamic tariffs coming onto the market, which incentivize people directly to use more during times when prices or tariffs are lower, which generally coincide with when renewable generation is higher. So there's a lot of figuring out to do in terms of the route to the customer. Who manages the customer? Is it the energy supplier? Is it the manufacturer of these assets, like EV charger manufacturers or battery manufacturers? Or we're seeing a lot of new business models coming through where new flexibility management businesses, I guess, are creating propositions for customers to enter into these programs. So really only scratching the surface, but there's huge potential for this going forward. Yeah.
Neil, you want to come in?
Yeah, it was just an interesting point that I think became much clearer during the course of the project, and that is the gap that exists with the communication with the vehicle. So the vehicle itself doesn't really communicate into the energy network at the moment, or the present generation of vehicles doesn't. So if you, as a driver, have set your car so that you don't want to charge it above 80%, then that only that 80% battery is available. Whereas if you actually had the ability for the network to go, okay, well, I've got some spare electricity, I'll stash it over and above your 80% limit, and basically override that and put extra energy into the car batteries. You can imagine that could become a thing in due course. But the cars are pretty dumb. We could communicate with the charger, we couldn't communicate with the car, so we didn't know how much charge could be put into cars at the start of any given event. And it does feel there's a gap there in the comms as a whole. It's been okay when they're just cars, but now they're not cars, they're part of the energy network.
Thanks, Neil. Gareth, do you want to come in as well? You're on mute.
It was also just to broaden it out and refer to the trials that have been done with National Grid over the winter, which I think most of us will have seen, on the news. And I think that was predicated before that with Octopus had done a trial to their customers. And I think it's really interesting that Orkney, through ReFLEX, has been able to mirror and perhaps tailor a trial to a slightly different purpose than is happening at that national and utility level. But it's designed to kind of solve Orkney's problems, if you like, through local solutions. So I think it's a good example of showing how the ReFLEX project is at the cutting edge of what the wider system's trying to do. And going back to Neil's point about how the energy system is a kind of microcosm of the UK system, it may be in the future that there's trials that can be undertaken through our through our ReFLEX customer base that could actually have national resonance as well. So thanks to everybody that's participated in that.
So there's a question here. Do you see ReFLEX being able to allow more renewables to connect to the grid, or is it mainly going to help with wind turbines that are already connected? Gareth or Neil, do you want to come in on that?
I think I said I'd take that one as a start, but I mean, I think it's a two-part. Initially, I expect they will help existing renewables that are there, because we know we've got curtailment of existing renewables. But the reason we don't have more renewables is that we know that the grid is already maxed out on occasion. So if we can make more space on the grid, then it can enable more renewables to come along. That's one part. Second thing is that we're also going to see dramatic changes in the number of vehicles. I mean, there are something like, I can't remember how the numbers are, but there are 10 or 11,000 vehicles on the roads in Orkney. At the moment, we're just in the sort of 600-700 mark with electric vehicles. So there's a huge growth going to be happening with the scale of vehicles. And so one, as Mark's point earlier was, the scale of charging that those vehicles represent as a group can now be mobilized, or we can see ways in which they can be mobilized, which then can help more renewables come to the network. So I think it's both.
Thanks. Mark, are you wanting to come in? Yeah,
I was just going to add to a few points there in terms of increasing the levels of renewable generation. That was entirely the goal of the ReFLEX project in terms of the generation side of things. Flexibility, demand flexibility can help to reduce curtailment, thereby increase the output of existing renewable generation. But we had also looked to introduce new renewable generation in Orkney through the project, namely in the form of behind the meter or domestic level solar, and coupled with battery storage. That was a big part of the scope of our scope of the project. In the end, it was just not feasible to do. I'll just answer the question on A&M operation in the chat there. You'll see which asked about whether A&Ms are set up to interact with or coordinate demand flexibility to help reduce renewable generation. They're not currently. The big issue that we had in proposing solar rollout in the project was it was viewed as a large-scale generation project by the DNO, and thereby would need to join the A&M scheme. But the tools and the systems weren't in place by the DNO to allow for that to happen. So ultimately, it wasn't feasible in the project. We've learned an awful lot. The DNO has learned an awful lot. We had a lot of interaction with Ofgem on this point. And I think the learnings from a place like Orkney, which are experiencing these kind of constraint issues before anywhere else in the UK, will be really important in designing and planning the network and the systems that operate them going forward.
I'm going to take a couple more questions from the Q&A and then move on to the next section of the webinar. So there's a good question come in here about the new grid connection to Orkney, and will that make enough space on the grid to remove the need for smart charger control? Mark, are you happy to come in on that one?
Who wants to go? And Neil's jumping at the bed as well, but the new connection. I'll go first. The new connection is primarily there to facilitate the export of new renewable generation, the extent to which it is connected into the existing system and will reduce current curtailment levels kind of remains to be seen, but it would certainly be a big part of alleviating the constraints that we have. It's obviously good for the Orkney economy that this is happening. I think it is now at the stage, though, where investing money in the building of larger power systems, power lines, transformers to manage peaks of generation and demand comes into question. We should be looking at using flexibility to avoid the cost of upgrading the grids where possible, given the very large capacities of flexibility that are going to be coming onto the grids over the coming decades. We need to start making more efficient use of them to have a more efficient grid, rather than one that is oversized to manage infrequent peaks on the network. So that's my initial views on it. Over to anyone else that wants to come in.
Evelyn?
If you don't mind, I will come in. I'll jump in for you, Neil. So SSEN are actually predicting that in winter 2031, the Kirkwall substation won't have spare headroom for demand. So that's because they're expecting so much additional demand technologies to come onto the network that actually there's going to be more demand than the substations can meet. So I think that coupled with new renewable generation is actually going to mean that the network's going to change quite a lot. In the north of Scotland region only, we've got targets to hit something like 30 gigawatts by 2030. We currently only have 8 gigawatts in the north of Scotland. So, there's huge amounts of new renewable generation that is needed. And I'm probably going off topic on the answer now, so I'll pass over to Neil.
I think John was going to jump in there. Actually, he's better qualified.
Yeah, just to say, I mean, the bulk of what Evelyn said there is going to be wind. So you've got that intermittency of the wind output, and I think as we decarbonise that 80% that Neil flagged earlier, in terms of where Orkney gets its energy from at the moment, over 80% of that is still from carbon. As we decarbonise that, the bulk of that is going to be through electrification and increasing demand.
And I'm just going to make a small plea for the fact that that's where the diversity of supply here really helps. So that's where tidal and wave in due course will also play their parts, but wind is going to do the heavy lifting in the near future.
Evelyn, there's another question here about the value and how much money Orkney loses each year through curtailment. Do you have that stat with the community?
No, I don't have that off the top of my head, unfortunately.
Yeah, we did a little bit of work before Lisa on this, and it obviously depends on the price of electricity, and it has been a lot higher for the last year, but I think we conservatively estimated about £1 million at its peak. So, there's a fair bit of money there potentially. Significant
losses there. Okay, final question from the audience just now, and then we'll move on to the next stage, but there's a good one here about the telematics. John, in terms of do people have concerns about having their EVs tracked by telematics?
If they did, at least we didn't get any feedback to that effect. We had people coming forward, volunteering to take part actually, and just want to be part of. And I think that's what's been great about doing this project in Orkney, that people are really engaged with energy and finding innovative solutions. So no, I don't think there's been any concerns that I've been aware of.
I'm one of the ReFLEX drivers, and I find it really interesting seeing the stats and being able to try and go, oh well, that's my car, and I'm part of that. So it's really interesting seeing the stats come out. Please do keep questions going into the Q&A, but we'll move on to a bit of a discussion topic now, particularly looking at some of the challenges that were encountered around the project. So I think it's fair to say that ReFLEX hasn't been just plain sailing. It's trying to create the energy system of the future isn't particularly easy. Who knew? But it's uncovered a lot of learning as we're sharing, but also letting us see where the barriers are within the current system as well, and what we need to try and overcome as everybody within the UK, what we need to do to try and overcome the challenges that are there. Don't have enough time to delve into a lot of detail around this, but we will be adding a number of case studies onto the ReFLEX Orkney website over the coming weeks. If you're wanting to delve into more detail, but I think it'd be good just to have a brief discussion at the moment on some of those kind of key barriers. I'm going to start looking at the sort of consumer regulations, and Anna, I wonder if I can ask you to come in on that, because I know the customer journey that we developed around a lot of the services, and for ReFLEX Orkney Limited, the initial aspiration was to have a sort of one-stop shop, but there's been some challenges around doing that.
Yes, we've found that because of consumer rights legislation, a combination of consumer rights protection warranties, grant funding rules, and finance meant that it wasn't possible to be a one-stop shop where people just dealt with our customer team when they were leasing a car, getting a charger, or anything like that from us. And a really good sort of illustrative example of this was that if someone leased a vehicle from us and got a charger from us, they would have to directly interact with 7 different organizations through their customer journey. And that was for legal reasons. So for example, they would start with us coming for the test drive and the local contact. Then once they were ready to get a quote, that would be from Drive Electric, our leasing partner, one of the UK's largest EV leasing companies. And they're a broker, so they would be, you would sign your lease agreement and they supply the vehicle, arrange the supply of the vehicle, but the finance actually comes from a separate company. So you'd sign your lease agreement at first with Drive Electric, but then your finance for your car would actually, you'd sign paperwork directly with that finance company. Then you'd have the installation done by RS Merriman's. And if you're applying for the 2 different charger grants that were available, one from the Energy Savings Trust through the Scottish Government and one through the Office for Zero Emission Vehicles from the UK Government, again, you had to apply directly for those yourself. So our team would sort of handhold people through that journey, and that was the service and help we could provide. And for some people, because a lot of that journey was online, older folk who weren't so tech savvy would even bring in their laptop and their tablet, and our team would sit with them and help them do that work, but they had to do it directly because they're legal agreements that we couldn't just take on and do ourselves. And that was an important learning and a real challenge. And it was something we got feedback from people, even when it was along the lines of, thank you for this help, because I couldn't possibly have navigated that without you. But people often said, as feedback, is there any way you could make this simpler? And that was a frustration and a challenge, is just to help people actually get through that journey.
Thanks. That's really interesting, Anna. I think it shows just the value of, again, giving this a try. You couldn't learn this stuff without actually going out and trying it. Mark, I know one of the offerings or the aspirations is to have an offering around solar and batteries. But again, there are quite a few barriers in terms of what we're trying to do there. Do you want to give an overview on that side of things?
Yeah, certainly. Feel free to jump in and cut me off if I start going off, going on for too long on this one. It was a big part of our scope in the project was to offer a funded solar and battery solution, both to social housing and private domestic. For a start, we knew we were going to have challenges with the grid in terms of introducing kind of high levels of new renewable generation onto an already constrained grid. But the challenges that we came up against were simply too much. It eventually turned out to just not be feasible, that the systems weren't in place currently to allow micro generation to join an A&M scheme. So one of the big challenges we had, we were looking to do somewhere between kind of 200 and 500 of these systems for domestic. And we constantly had to kind of reduce the kind of target levels because of the challenges we were seeing. What it came down to was the view that introducing new generation onto the Orkney grid would lead to higher curtailment of existing wind generation. And with the systems not being in place from the DNO to allow smaller renewable generation to join the A&M scheme, it was going to be a significant cost to develop those systems to allow that to happen. So in the end, it was quite frustrating that the levels of new generation we were looking to bring on would not have had a meaningful impact on existing curtailments. Generally, wind and solar are out of line in terms of when their peaks occur. So that was a bit of a frustration, but what it came down, another big issue, I guess, was if we had developed the systems and SSEN had developed the systems to allow these that microgeneration to join the A&M scheme, we would have had periods where the generation from solar would have been curtailed, not just preventing export out into the grid, but curtailment would have been at the the point of generation, basically meaning that solar would not have been allowed to self-supply the consumers on whose homes they were installed. So that was quite a frustration. We believe there's a hole in the regulatory system which needs to be addressed on that point to allow, we believe, a fundamental right for self-supply. The offering to customers that we were looking to bring forward was heavily discounted on-site electricity supply from solar. The kind of rates that we were proposing to sell on-site generation to the customer were around half, in fact, less than half of the average tariff rates, grid supply tariff rates in the UK at the moment. So it was a good idea, but one that just simply wasn't feasible in the end due to the number of barriers there. Again, you learn 10 times more when things don't go right, I guess. So what's really important, I think, from that particular aspect in ReFLEX is that we take the learnings, feed them back to people like Ofgem, policymakers, so that they're aware of the issues of trying to add more and more renewable generation to an area that already has high levels of it. So we're heavily involved in that feedback and looking to ensure that these learnings are considered by those that are making decisions on how the grid operates. So hopefully that's a helpful summary on what was a pretty complex situation.
Definitely. It sounds like there's almost a catch-22 there in terms of the ReFLEX project is trying to help alleviate some of the curtailment, but we're also pushing against the barrier because there was a concern that we would create more curtailment. So it feels like there's just a bit of a catch-22 there in terms of transitioning to a new energy system. Neil, do you want to come in on that point?
Yeah, and I think it's also really worth stressing that one of the things we were trying to tackle was trying to deal with the fuel pause problem. In other words, actively trying to engage with social housing to try and put in these schemes, and to be able to supply energy to those who are least able to afford it is really, really important, because at the moment renewables has got a little bit of cachet about it. It's a middle class preoccupation. It's okay if you've got the money to go and do this stuff, but we were deliberately trying to target groups which have not necessarily benefited from the energy revolution at the moment, and so that was particularly galling. And can I just go on to another point here, Lisa, which is also about the grant side of things, which I think is sort of rubs up against what Mark was talking about. As I understand it, one of the challenges we had with dealing with some of the social housing providers was that there were certain schemes around, particularly the eco scheme, the eco3 scheme, and then there's a proposal for the eco4 scheme coming along down the road. And as a public provider, they had to be really careful that they were getting them the most bang for their buck. And so there was a reticence to be able to sign up for certain schemes because they felt there was a better scheme coming down the track a little bit later on. And so the problem there was, by waiting for the later scheme, quite rightly, to make the most of the money, progress didn't happen. So there does feel as though there's an opportunity here to better understand the stop-start nature of funding for support is counterproductive. And indeed, there is a way to patch that slightly, which is that maybe there's a need to have a commitment by government, which is if you're going to have a scheme now and you're going to have a later scheme coming along, if you could assure the people in certainly the social housing space that there will be no detriment. If they've signed up to Eco3 and Eco4 is slightly better, that there'll be a mechanism to recompense that difference. And in that way, they would actually have the confidence to commit to 3 and get on with it rather than wait for 4, hoping it's going to be right. And I think we definitely saw on a time-based project like this, that was a problem that we really weren't able to fight our way out of. And so a plea to government there would be recognizing that there are costs associated with there always being another scheme coming along, and there might be, well, we can see better ways of dealing with that.
That's really interesting. Yeah, thanks for that. And we've also had discussions just thinking around the sort of grant funding side of things in terms of state aid rules, and particularly the imperative to get on with the climate crisis. Any thoughts on that, Neil?
Yeah, how long have we got? Another couple of hours, will that be all right? Yeah, you're right. I mean, one of the one of the edicts that everybody's operating under are some of the state aid rules. And I'll just point out that Moses did not come down from the mount with the state aid rules written on one of the tablets of stone. You know, these are something that have been written at various times. And I think at the moment we can see that there is a need to make sure that if we're going to start tackling climate issues properly, we may need to slay one or two sacred cows. And indeed, we've seen things like in the States, the Inflation Reduction Act actually starting to make some serious dents in some of the things that were being regarded as sacrosanct before. So the particular challenge we came up against was that, and it became very clearly illustrated within the project, that the partners have all got very different statuses. So EMEC is not for profit. Community Energy Scotland is a charity. I think your charity, aren't you, Evelyn? Just, yeah. We had Orkney Council in here as well as a local authority. And so we were able to be effectively 100% funded for some of our activities, whereas others, being small and medium-sized enterprises, could either get much lower, what they call intervention rates. And indeed, we had some big participants in which could only get about 1/5 of their they could only claim about 1/5 of their costs against the project. And the point there is that if we want things to happen, we have a system at the moment which is very much focused on minimizing the cost to the exchequer, as opposed to a system which is absolutely seeking to get progress as fast as possible. And so at the moment, the rules mean that there is a very high concentration of activity around making sure we don't transgress any state aid rules about being able to fully fund activities which would be deemed to be inappropriate. Now, from our point of view, we strongly believe that there is a need to challenge that in these innovation spaces, because we need people to full-throatedly and wholeheartedly commit to these projects and get after them. And if they have to do a lot of internal wrangling with their own finance committees to find out how the other 4/5 of the money is going to come from their finances rather than grant monies, then that's going to be really important. I'd just like to reflect on the point that you made right at the start, that this was a jointly funded project between ourselves and UKRI. And the point is that 50% of that funding had to come from the private sector. And that was the original intention. And in fact, that proved to be very difficult to do in some of these innovation spaces. So we would urge that actually those rules need to be fundamentally rewritten if we're going to tackle the climate change problem seriously. If we want to keep playing with it, that's fine. But actually, if we want to really muscle up and go with it and do as the Skidmore review said, which is go early, go hard, and go now, you know, we really do need to consider changing some of those fundamental rules.
So there is a key question here in terms of how we're going to finance that transition to a clean energy system. And Gareth, I can see you put your hand up, so do you want to comment on that one? You're on mute, sorry.
I'm just enjoying it so much. I'm just listening to what everybody else is saying. Yeah, I thought this was maybe a good time to kind of lift this up to the highest level in terms of how do we finance the transition. I think you've got a slide there that you might be able to find it while I'm speaking. But obviously we know that energy is really expensive, and it's got much more expensive recently. But one of the opportunities that ReFLEX gave us is to have a look at that in a bit more detail. And on this slide, we've got a kind of, on the top side, it looks at a business as usual, which I've described as a late transition. And on the bottom side there, it looks at the ReFLEX approach, which is an accelerated transition. And if I start with the top, we had a look at obviously how much we're spending on energy at the moment, and how much we spend on energy is obviously how many electrons we buy from the electricity provider, how much fuel we buy, how much heating oil we buy. But it's also about the tools and the equipment and the buildings that we have to use that energy, if you like. So, you know, if you invest in household insulation, then you'll get an energy dividend. You won't have to use as much fuel, but you have had to put the capital cost in to insulate your house. If you have a kind of petrol guzzling car versus a small car, there's obviously a different makeup there. And then there's also the energy that we use by accessing services that others provide. And when we started looking at the situation in Orkney, we found that not only is our kind of household energy in terms of heating use much higher than other places, but our carbon use in terms of transport, as Neil indicated in the audit, is very high as well. So the result of that is that we have a kind of energy or carbon bill, if you like, that's probably twice that of other parts of the UK on average. And of course, within Orkney, that isn't the same for everybody. If you're out in one of the outer isles, you might well have an even higher energy budget than somebody that's, say, in the middle of Kirkwall or one of the other settlements. So, yeah, so we're already paying a lot for our energy. And if we add all that together, we came up to a figure of about £10,000 to £15,000 per household, which was typical for not only the energy we're using, but the tools that we use that energy with. So if we just take a basic assumption of 10,000 homes across Orkney, it's a bit under what the figure is. That translates to a spend each year of 100 million to 150 million pounds in Orkney for energy in our households. And on top of that, we obviously have the industrial and public sector use. And if we take those numbers and then think about the next 20 years, it comes to an incredible £2 billion probably in our next 10 years and £3 billion given the energy inflation over the next 10 years. So it's quite conceivable that we might spend somewhere between £3 and £5 billion under business as usual at the moment. And that's all built up from each of our households spending the £10,000 to £15,000. And one of the challenges for that is that at the moment, 40% of that is probably taken up with the capital of the equipment and the facilities, and 60% of it is the operational cost of the fuel and the electricity associated with it. So what ReFLEX was looking at is, well, if we put renewables into the mix, can we actually reduce those future costs in terms of fuel, because we're actually using effectively fuel for free from wind, waves, tide, etc. And so we started looking at what it might take to invest in a house to convert it. And I've just taken a notional figure there, which is generous, but £100,000 for electric cars, for insulation, for equipping that with energy efficient solutions, and also a contribution to some of the services that we access. And if we then multiply that by the 10,000 households, we come to £1 billion. But we've also got the industrial and the community, the public sector part to do, which we think in this case is going to be a bit bigger, £1.5 billion. But the total bill then is maybe £2.5 billion in the next 10 years, which is more than we would have been spending as business as usual. But we get a really good dividend once we've invested that capital, because the costs collapse and we're not having to spend it on the fuels going forward. And so over the 20-year life cycle, we might be spending under or around £3 billion. Now that could be roughly equivalent to business as usual, but what you can see is we've insured ourselves against this energy expensive future, and the risk of the energy prices going up, we've avoided that. So we've avoided a possible increase of £2 billion above what we're spending. So this is at the crux, I think, of what ReFLEX is trying to do. We're trying to find a mechanism for accelerating the spend into technology, which insulates and insures us against price volatility in the future. And you know, the other parts of the presentation have talked about how different regulations and mechanisms get in the way of that at the moment. And you know, so it is about trying to create a new business model. But I come back to the point actually that ReFLEX was a pilot project specifically to illustrate where these blockages might be. And I think that what we've tried to share today is where some of these things that we've recognized that are getting in the way of going for an accelerated approach. And we're far better prepared now to go to funders, to go to investors, and to get them to support that introduction of accelerated capital than we ever were when we started off 4 years ago. So the fact that we've had the difficulties has given us the chance to make the learnings which have better prepared us for going forward in the future, hopefully.
Thanks, Gareth. So I think we're needing to draw the webinar to a close shortly, but I was just wanting to very quickly kind of cover some of the next steps and where do we go from here. So just as a starting point, if you go on to the ReFLEX Orkney website, we are in the process of uploading a whole series of case studies and various different reports around the lessons learned within the ReFLEX Orkney project, and we'll be sharing some of that learning through our newsletter over the coming weeks as well. So please do sign up to the newsletter or keep an eye on the website for that learnings as it gets uploaded there. And we are actively engaging with various stakeholders around the energy industry to make sure that we can feed these learnings into the relevant people to make sure that they're taken on board for future projects and future funding schemes that might come through to support these projects. In terms of ReFLEX Orkney Limited, John, do you want to come in with the next steps for the business?
Yeah, very much so, Lisa, and it's onwards and upwards. The focus for the business will be the accelerating decarbonisation and doing that in an affordable way as possible, and wherever we can, we want to do this smart energy integration, so use energy in a smarter way as possible. So over the last 2 years, as you've seen today, there's been a lot of discussion about EVs, and that is really provided a great foundation for the business. And we're very active out of Hatston, both in terms of serving customers in Orkney and across the UK. We provide EVs across the UK. I think in the last month we've had 11 sales. 9 of those have been outside Orkney, 2 of those have been within Orkney. So things are very, very active. But we want to build on those foundations and provide services in the heat and power market, as we touched on earlier. And I think the gap that we've identified is, whilst there's a lot of different technology solutions out there and a lot of grant schemes, as a consumer, and I know this myself, it can be a bit of a minefield in terms of what do you do and when and how do you get it funded. So what we're looking to do with ReFLEX, and hopefully roll out some further details on this over the coming months, is basically help customers on that journey. So whether you're a resident in Orkney or whether you're a business, the idea is that we will help you on that decarbonisation journey, as we've done with the EVs really, but we're looking to do that more in the heating and power space going forward.
Yeah, and the car club is going to be continuing as well. If you're not already a member, you can sign up at co-wheels.org.uk. So Community Energy Scotland and EMEC are going to continue to financially support the car club, and the cars at Kirkwall Pier and in Stromness are actually going to be replaced with new MG4s. So an MG4 is an electric family hatchback. It's got room for up to 5 people and a range of more than 200 miles. It won 9 awards last year, including Car of the Year. So really excited for those to be delivered this week. The MG ZS is going to move back to Somerville Square. So this year there's going to be 3 cars that are available to book as part of the car club in Orkney, as well as all the other car club locations across the UK. And we're sharing lessons about what's happened with the car club with other community groups and councils through other projects. And Anna, I know there's a number of projects that are going to pick up on sort of the demonstration elements of ReFLEX. So I wonder if you could give a quick summary.
Yep, absolutely. Lisa, I don't know if you're able to share that slide, possibly, if you've got that to hand. Yeah, basically we've got, I mean, people often think with projects, you worry that the learnings will wind up on a shelf, but that's definitely not the case for ReFLEX. We've got 4 different projects, 3 of them literally kicking off as we speak, that are designed to take the learning from ReFLEX and other work in the decarbonisation space in Orkney forward. So we've got 2 net zero living projects, one for Orkney and one for Shetland, which is the Shetland project is collaborating with organisations based in Orkney, and both of them are funded by Innovate UK. And the purpose of these projects, they're 2 feasibility studies to specifically look at the learning from the non-technical barriers, so finance, regulation, things like that have come out of projects like ReFLEX, and look at how we can overcome those barriers. And these are short studies, but it's phase 1 of a much longer piece piece of work by Innovate UK. So we're hoping we will be bidding for phase 2 with the learnings we have from this, which will hopefully help to overcome non-technical barriers and accelerate decarbonisation. Then we've also got the Island Centre for Net Zero is officially getting going now, which is a collaboration between Orkney, Shetland and the Outer Hebrides. It's a 10-year project, so much longer term project funded by both the UK and Scottish governments to support decarbonisation in the islands. And then we've also got the Carbon Neutral Islands 2040 project, which has the aim of to decarbonise 6 of Scotland's islands by 2040, and that's funded by the Scottish Government and has islands across Orkney, Shetland, the Outer Hebrides, Inner Hebrides, Skye and the Clyde area as well.
Thank you very much for that. So yeah, certainly making sure that the learnings and the value that's come out of the ReFLEX project is there and fed into multiple projects that are coming up in future as well. So that's us kind of drawing to a close for the webinar today. Just wanted to thank everybody for contributing. So Neil, Gareth, John, Anna, Mark, Evelyn and David. That was really interesting presentations and discussions there. And thank you very much for everybody for tuning in. Neil, I was just going to pass over to you as project director if you had any final thoughts to give before we end the webinar.
Thanks, Lisa. So I'd like to just reiterate my thanks to everybody who participated both in the webinar, but also all the work that's gone on over the last 4 years. A little learning tip we would have is try not to do a project like this during a war and a pandemic. And if you can avoid those, that will certainly help your progress quite a lot, we think. But I really just want to say a sincere thanks to UKRI and for the faith they showed in the community in seeking to try and tackle this. We know that there is a need for a revolution, an energy revolution, and we absolutely know that the current system is not going to deliver it, so it will require change. We're really up for continuing to challenge and find ways of doing things differently and doing things better. So we are grateful for the chance we've had to do this. We believe there's so much more that can be done, and frankly, if people want to come and see what's going on in Orkney, please do keep an eye on us. We're not going away anytime soon, and we'd be delighted to share our learnings that we've got, through the various vehicles that have been created. So thanks again for everything that's gone on, and watch this space for the next bit. Lisa.
Thank you very much, everyone. Have a good day.
Bye.
Thanks, guys. Bye now.